Okay, good afternoon. Today, this lesson will be on the analysis of arch. Okay, I will show you two examples on how to analyze for the three hinge arch. Okay, so let's have a look on the learning outcome. By completing this lesson, students shall be able to determine the rise or y, okay, at any point of the arch. Means that we want to determine the height of any point, okay. But in this arch, the terminology we use rise. And then to determine the support reaction of statically determinate three hinge arch, okay. To determine the internal forces, okay, such as radial shear force, bending moment, and normal thrust values in the statically determinate three hinge arch. And I think after this example, I have also shown on the bending moment diagram, okay, of this statically determinate three hinge arch. So this is a reading materials for the first few slides. Okay, if you can see that, I will go through, maybe I will look at which is very important for us in the analysis. For example, okay, so these arches, oops, so these arches, okay, so actually work under compressions. So when you have an analysis later on the arch, let us see whether this is true or not. Okay, so of course the arch carry all the load, and then here it mentions that this is usually dominantly permanent load case. So also means that the dead load here, okay, it is good, okay, in carrying such loading. Okay, of course it also carries live load, or nowadays if you are using Eurocode, we term it as variable loads. Okay, in the Eurocode, this live load, if you use to BS, oops, I'm sorry, used to BS 8110, okay, you use live load, okay, but in the Eurocode, this has been termed as variable loads, where you deal with the loadings that is not permanent, okay, at the location, okay. So it can be comes and goes, okay. So for example, the arch, if it's being used for let's say the bridge, so the live load here will be something like your vehicle loads, or if you are working on the bridge, okay, these are considered live load, okay, not permanent at the arch, okay, the structure. So now let's have a quickly look on the terminology of arch. It may not, it may have different names, okay, but this is what I have provided here, okay. So now if you look at, we have these springing lines. These springing lines is actually the point at where the arch touches its foundation here. This is a the springing lines or spring line, okay. So and then the rise, okay, in our objective just now, is the vertical distance from midpoint of the chord joining the springing lines to the axis of the arch, okay. So we have this height, okay, and the span, okay, is the length of the horizontal projection of the chord joining the springing line. So now you have spring line to spring line. Okay, now you need to find where is the center of this support, then this will be your span. Okay, or sometimes you use L, okay, in measuring this. And then the crown will be the point on the arch at the midspan. So this will be the top, the highest point of the arch. Okay. There are different types of arch, and the advantages and disadvantages, and the degree of determinacy, static determinacy of the arch. Okay, we will focus now in chapter 1 in analyzing this 3-hinge arch. Okay, so this is a statically determinate. How to prove it? We can use these equations for beams and frame. Okay, where D is equal to R minus N minus C. Okay, in this case we have this is beam because we have 3 hinge, right? Okay, this is also beam, and this normally we call hinge. Okay, so now we have R is 4 minus the 3N is equal to 3 and minus 1. Okay, for the hinge. Okay, you get D equal to 0, which is a statically determinate structure. Okay, you can have a reading later on what are the advantages and disadvantages of this arch type. Okay, it will be useful when you need to decide which arch you need to provide for this project. Okay. So what is the difference between the arch and the beam? Okay, so if you look at here, the beam, we do not have horizontal force. Okay, I shall say that in common, there is no horizontal force. Okay, unless you place an external lateral force or that sloping loads on the system. Okay, therefore we will not have any axial force in this particular beam case. Okay, the axial force is equal to 0 here. Okay, and when you determine the MB, okay, for this system, okay, you straight away using the AY multiply X. Okay, but for the arch, we will, even though there is no horizontal or force, no external load on top of this system, okay, so due to this surf weight, okay, we will have this axial force exist. Okay, so and the H here will have some value. Okay, so to get the MA of internal force of the cut sections, okay, we will need to multiply the R, okay, which is this vertical support reaction, okay, multiply with the perpendicular distance, which is the X, and this horizontal reaction, H, multiply with the perpendicular distance we will refer here now is Y. Okay, so you will get the MA. If you can see that, yeah, the difference is here. Okay, and the 3-hinge arch. So here I show you the procedure of the analysis of this 3-hinge arch. You need to understand that this C, there is a hinge at C, and therefore moment is equal to 0 at this point. Okay, so we can't, if we cut a section at AA, okay, you can't draw the free body diagram of AC, section AC, and also section BC as such, okay, where you need to put in your support reaction AY and AX because this is pin, and the CX and CY at the hinge, okay, and there is no moment at C. Okay, so whatever you have decided on this direction for your CX or CY, it shall be oppositely placed, okay, for your section at BC. If you can see that, CY going down here and coming to section BC, it is going up. Why? Because we need to make sure that summation FY at this particular joint at C equal to 0. Similarly, for summation Fx. Okay, and moment, there is no moment at this hinge. So by using this concept later, we can determine the support reaction and some of these forces. Okay, so now we can look at this procedure here now. This is very general, okay, where you determine the support reactions, and then you can determine the rise, okay, the Y, and the angle of theta. The angle of theta here to this angle at any point, okay, of at the arch, okay, because we need to use these angles to resolve forces. Then we can determine these internal forces. These are the internal forces, okay, shear force, axial force, and the bending moment. Of course, it's being it use a slightly different name like radial shear and something, okay, because they are talking about a curve, okay, but still it is perpendicular to that cut section for the shear force, and normal force is running out, okay, parallel with that particular section, and the bending moment is at that point, okay. And then we can use this information to generate the outputs, like you want to draw a shear diagram, axial force diagram, bending moment diagram for your design, okay. So in this case, I will show only on the bending moment diagram. So now there are two types of these three hinge arch that I will show you in the example later. Wait, am I still in the class? Let me check. All right. Okay, we are still waiting another one students to join us. Okay. Are you okay, class? Just to make sure.
Okay.
Yeah, okay. So let us go back to the slides. Okay, so now we have two names, two arch. Okay, actually they are both three hinge arch. Only the shape of the arch is we categorize it or name it differently. Okay, one is a parabolic arch. Okay, where you have a parabolic shape. And then another one is circular arch, where if you draw it with this radius all the way, so you get this full circle. Okay, so let's just have a look on these equations. But I'm not going to show you the derivation of the equations uh, in this video. You can have a reading later. It is in my slides, okay, in a few pages later. So you need to take note on these equations. One, a very useful equation is to determine the y. What is the y? The y is this height, okay, any height at any point of your arch. Maybe you want to determine here. Then let's say this is k. So you want to determine the y at k. So we are talking about the height. Okay, if you are dealing with parabolic arch, you can use this equation. Okay, so let's go through quickly on this equation. We have YC. YC is the rise, okay, or the maximum or the height from the spring line to the crown. Okay, remember just now we have this crown, we have this spring line. Okay, so this is the rise, YC. Okay, you need to put in the YC, and the L is the span. Okay, L is the span. just now we have mentioned that the span runs between the spring line. So you need to identify where is the center of this spring line. Then the distance in between this is the L. Okay, and the X. The X here is what is the horizontal distance from your left support. Let's say if you want to find the K, so now this will be your X. Okay, so putting all these informations into this equation, you can determine the YK. Okay, so but if you are keen in why this, how to derive this equation, you can refer my few other slides. Okay, I have shown you a detailed calculation on that. So for circular arch, okay, we can use this equation to determine the y. Okay, where you need the r is the radius. Okay, this radius is you need to it shall be known to you. Okay, so if it is a half circle, then you will know that this will be your radius, where this is your O. If this is half circle, okay, but this is not, right? So the O is here and the radius here. So you just need to determine or find out what is your radius, and then you have two angles to refer. So first of all is theta, and then another one is alpha. So how to get the angle theta? The angle theta is, let's say you want to find K here. Sorry, the Y, the height at K. So which is the YK. So you need to join K, okay, to the center of the circle, which is O. Okay, then this O you can put it in a, I mean, straight line, okay, or going to your crown. Okay, then this will be your let's say this is your y-axis. Okay, so this angles between the drawn section will be theta. Okay, the other alpha is obtained by drawing this O to your spring line. Okay, so this will be your spring line. So now you have alpha. Okay, so I hope we can use these two equations. I will show you how to use this equation in the real application later. Okay, so okay, and then if the radius is not given to you and it's given to you only YC, what is the YC just now? The rise. Okay, YC is this one, the rise from here, spring line to the crown. Okay, you can make use the YC and the span. Okay, okay, to determine your R. Okay, of course, if you want to know about this, it will be in your, I mean, the slides later. Okay, what else? This another equations here. If you want to get the theta for this one, the angle, okay, you can use this equation. Okay, tangent theta is equal to dy over dx, where this is also equal to this 4yc over L squared, L minus 2x, where you actually differentiate, okay, the y. This equation 1, you have to differentiate it and become this the equation 2. Okay, so meaning that you just need to remember your number 1, equation 1, and you can make a deviation if you have the knowledge on that. Okay, so now let's yeah, this is the derivation of how to get the y, how to get the theta. Okay, you can have a look. Okay, I show you step. Okay, and then you also can have a look on what is this? Wow, I put it 3 pages. Okay, maybe my explanation from this page probably. Yeah, this is a whole solution, and I cut yeah, to have a more detailed step by steps. Okay, and the derivation for the circular arch also I have include here in the slides. Yeah, you can have a look on that. Continue with this derivation. Oh, more explanation. Okay, so now I would like to show you on how to determine the bending equation, or calculate all the support reaction, and also to calculate all the internal forces like bending moment, normal thrust, radical shear at this point X, okay, in this semicircular arch. Okay, so it is being given to you here. It is one type of circular arch and it is semi. Okay, so let's have a look on the system. Okay, the arch. Okay, we have the hinge. Okay, we have pin supported. We have EYAX at A, BYBX at B, and then we have 60 kilonewton. We have 100 kilonewton, and our point of interest is at X. Okay, and several angles have been provided in the to you in order to determine these internal forces at X. So what we have to do now? Okay, so I want to determine support reaction. Okay, so what I can do here is, okay, this is my process. Okay, when the support at the same level, okay, you can always just take the summation moment at A or B. Okay, let's try. Okay, so then we need to take summation moment. In this case, we take summation moment at B equal to 0. Okay, so now I need to include AY, AX, 60 kilonewton, and 100 kilonewton. Okay, to be able for me to gather all the information for MB. Okay, but I do not have the distance, okay, from 100 kilonewton to B and 60 kilonewton to B. What I have here is 6 meter only. Okay, so which also may I know, class, what is my span for this arch? Can you help me? Hi.
12 meter.
Thank you very much. Yeah, because this is circular, right? Semicircular. Whenever you have a circle, okay, if you have identified this is your O, okay, so whenever from O going touching your arch, it will be the same distance, same length, okay. Therefore, come to here, we have also 6 meter from A to O, also 6 meter. Okay, the span will be 12 meter. Thank you very much. And then now I would like to look at this 100 kilonewton and 60 kilonewton, and I also include directly the X. So what I need to do is just to use the trigonometry, triangular geometry. Okay, so now what I can do, let's say I draw the 100 kilonewton. So what I actually draw is like this. Okay, I just draw a triangle in such. Okay, so this triangle is actually, I can draw it outside here. I just give it the name x1 and y1. Okay, so 100 kilonewton is here, and then we have a 30 angle, 30 degree, and we have already know the hypotenuse r. Okay, so you can get the horizontal and also vertical, the base of the triangle and the height of the triangle directly from the system. How? When you want to get the vertical, you use In this case, the R resolved into Y, you use 6 cos 30. Okay, so if you want to resolve this length to horizontal, okay, where it is opposite from this angle, okay, so you use R multiply sine 30. Are you okay with that?
Okay.
Okay, okay, yeah. Oh, all right. So, so again, so now you can just use the sine 30 or cos 30 to get your x and y. Okay, but you might you might confuse. Okay, when to apply the sine, when to apply the cos. Okay, so when you resolve a close going close to your angles 30. Okay, when you resolve that, so you use cos 30. But when you resolve the x1 is right now here. Okay, so your this 6 meter you want to resolve away from this 30, so you use sine 30. Okay, so similar process also used to determine the x2, y2, x3, y3. Okay, how to generate, maybe I will show again how to get this x3 out from here. So it will be from, just draw this triangle. Okay, I'm sorry I cannot use other pens, other colors. So this now is the angles. Sorry, is the triangles that I'm intend to determine my x-ray. And the angle here will be 60 degree. If you can see that, 30 plus, I have hidden myself the things. Okay, it will be, this is 15. I suppose. Okay, 15 plus 15 plus 30. Okay, so you get a 60. Similarly, you can draw the triangle for your uh, the location of to determine the x2 and y2. Okay, once you already have all these length, the x1, the x2, and x3. Okay, we can determine the uh, uh, moment at B, about B. So now let's have a look. AY, okay, this is just too messy. Let me just erase this and come back to the slides again. Okay, so now I want to take a moment about B equal to 0. Okay, so I have sorry, I need to put my pen. Okay, so I will need to take the AY, multiply with the length to B. Perpendicular will be 12 meter. So now I have 12 times AY, done. Okay, it is acting clockwise. Okay, as what I have assumed, so positive. So now my next will be 100 kilonewton. Okay, so 100 kilonewton, earlier I have determined this is x1. Okay, so x1 is 3 meter. Okay, so now my 100 kilonewton need to multiply x1 plus 6. Okay, because I need to know the whole distance up to B. Okay, so this is x1 plus 6 meter. Okay, then this is acting counterclockwise. Therefore, I have a negative here. And the next will be 60 kilonewton. Okay, so where you have this distance up to here is x3. Okay, you need to plus another 6 meter. Okay, to reach here. So now your x3 is 5. So you have 5.2 plus 6 here. Similarly, this is counterclockwise. So you put a negative. Therefore, you can straight away get your AY. Okay, so from after you get this AY, you can use the summation FY, okay, to obtain your BY. Okay, but you cannot, okay, determine the AX if you considering the whole system. Therefore, please utilize the hinge. Okay, what we can do here is we cut at the hinge. Okay, so we provide a cut section at hinge and we draw the free body diagram CY, CX. Okay, and we make taking the MC equal to 0. Then you'll be able to get your AX because you already have your AY, right? The AY is 131. So only one unknown in the system. Okay, so how we do that? So here, oops. Oh, I show here is 2 sections. Okay, but now I consider section CB here. Okay, but no worries. Okay, we're taking still taking MC equal to 0. Okay, BY we have already obtained is 29 kilonewton. Okay, so now in this system, we know that this is O. Okay, we have a radius of 6 meter. Uh, to get this C, remember this is a crown. Okay, so now we have 6 BY. Okay, this 6 BY is from this 6. Okay, and it is acting counterclockwise. Okay, and then 6 BX. And this BX is multiplying with this 6. Okay, so now you can solve for your BX. Also 29 kilonewton, then taking summation Fx, you solve for your AX. Okay, class, do you have any question up to here?
No, madam.
Okay, so now I can put a summary. I have determined all my support reaction, X, A, Y, B, X, B, Y, and I can also continually to determine my internal force. Okay, so okay, now I want to determine the internal force as X. So you need to be able to draw your internal forces at X. For example, this is your NX. Okay, this is your NX. Then this is your VX, the shear. And you will have moment. Okay, so previously we have said that try to draw a positive sign, but in this case, the NX is drawn negative sign. So you need to be take note that the NX, if you get a positive, meaning that it is compression. Okay, because as we have read just now in the first few page, okay, arch is normally in compression. Okay, let's have a look whether it is NX is positive or not. Okay, so now we need to also know that how to get this theta. Okay, because this theta, okay, will be used here, this and this. Okay, so let's go back to my earlier slides. Okay, on using this formula, the equations that I have shown you earlier. Okay, this is a revision. I put it just now. We have seen these slides. Okay, on how to determine the y. Okay, let's try to use this equation. Just now we have determined also the y, 4.24 meter, but this is by using the triangle. Okay, I think if you are comfortable with this, you can proceed with this. But as I promised just now, I want to show you on how to use the equations. Okay, so let's have a look. Okay, we have to put in the R. The R in this system is 6 meter. The radius here is 6 meter. And we need to determine the theta and also the alpha. So now the alpha here, to get the theta done, again we draw to the X. okay, the point of interest, okay, and the angle with the y-axis. Okay, so this is the theta. Okay, is that given to us? Let me check. Yes, okay, it is given to us 45 degree. Okay, so wait, am I still recording? Okay, let's go back. Okay, so now the alpha is we draw this O, okay, to the spring line, and then this will be the, and then angles will be taken from this line, okay, that we have drawn with the y-axis. So you get the alpha is 90 degree here. So you just put it in this equation, cos theta minus cos r cos alpha. Okay, then you get the 4.24 meter, which is the same as what you have used from solving the geometry of triangle. Okay, so next, okay, once we have already know about this angle, where have I shown? Okay, it's here. It's here. Okay, so maybe not that clear. Okay, now when you want to determine the internal forces at X, okay, you are drawing this tangent line, okay, through this X, okay, which is on the arch, okay. So this theta 45 degree here, okay, should be the same, okay, with this 45 degree. Okay, this is what I would like to highlight here. Okay, you need to make sure you understand the way to get this theta. Okay, the theta, okay, 45 that we want to use later to resolve forces is actually taken from this theta. Okay, so now let's go back, okay, to here. Now we already determined our AX, okay, our AY, okay, we have the theta, we have the height, and we have all this how to get this 0.96 meter and 1.76 meter. Let's go back to what we have just now. Okay, 1.76. Just now we said that from here to here is 1.76. Sorry, it's not to here. Oops, it's from A to X. 1.76. Okay, so how do you know that this is 1.76 meter, class?
Minus.
Sorry?
6 minus the length.
6 minus what?
Length from X.
Okay, 6 minus uh, 6 minus x3?
Yes.
6 minus x3. We got 0. No, 6 minus 4.24.
X2.
Yes, 6 minus x2. Because I'm talking up to x. X. Okay, because we already determined this x to this center of this rise. Okay, so it's x2. Okay, so 6 minus x2, you got 1.76 meter. Just to make sure you know way to get the 1.76 meter. And then another one is 0.96 meter. 0.96 meter is measured from 60 to x. Let's see. 0 here. This one to this one is 0.96. How to get 0.96 meter, class? Now this, to get this, is 6 meter minus x2. How to get 0.96, class? It will be x3 minus x2, right? Because the total length to the rise is x3 from 60 kilonewton, and from x is x2. So x3 minus x2 should get this 0.96 meter. Are you okay, class?
Okay,
Yes.
madam.
Maybe my I have sketched my board so messy right now. So later you may take note how to get this 1.76 meter, and make sure you know how to get this 0.96 meter. Okay, so let's go back to our analysis. Okay, now we have all these geometry solved. So we can just take a moment or take a summation fx, summation fy, to solve all these internal forces. Okay, what we have here is we get at the point x, horizontal forces fx at x, and vertical force Fy at x. Okay, you need to understand in this, at this particular x, there are two forces acting here. Okay, which is due to this nx and also vx. Okay, but now we want to solve this equilibrium equation in the global axis. Okay, global axis, I think I already mentioned to you in my previous class, where we are talking about this x and y. Okay, so everything shall be resolved in this direction, x horizontally and y vertically. Therefore, this nx and vx, which is not happen to be here, you need to resolve to this direction. So now what we can do is we resolve all the horizontal force from these two forces. So we have nx, okay, cos 45, okay, because we are resolving to here, okay, and the vx, we are resolving away from the angle, so we have vx sine 45. Okay, so vx is going to your right and nx is going to your left, therefore you have a negative and positive here. Okay, so then you need to resolve forces into the vertical y. Okay, so how you do that? Now I'm not considering this anymore, I'm considering vertical. So my nx will be resolved into vertical in such where it is away from my angle, which I use sine, and s sine 45. And this vx, I need to resolve vertically, which I resolve towards the angle, so I use cos, okay, 45. And both of these forces will resolve downward. Okay, therefore you have a negative here. So now you have two forces, okay, acting at this here at this point x. Okay, so what we can do here is we take a summation Fy equal to 0, okay, and then taking summation Fx equal to 0. Okay, so for this, can you write it here for me in your notes? Okay, this is a section. We are talking about a section AX. Okay, so now in this system, I have, can I erase this? Wow, wait. Okay, so this is section AX. So A is here. So now considering this section AX, taking summation Fy equal to 0, I will have this 60 kilonewton. I will have this 130 kilonewton. And then I will have this vertical force, okay, acting on this X. So now I'm putting all these forces into it. Negative 60 because downward, plus 131 because upward, and also this vertical force, okay, at X. Okay, so now I can equal to 0. I can establish my first equation. Are you okay, class, until now? Do you have any question for me?
So far, no question, madam.
Okay, thank you. So now I would like to quickly proceed to summation fx. Okay, so summation fx, I look at, maybe I use rectangle right now. I have horizontal force 29 kilonewton and the horizontal force at x. Okay, so now I can quickly put in my equations. 29 because following my positive sign, and also this nx and all these from the x, point of x. Okay, so I have established now the second equation. And now this equation 1 and 2 involving the unknowns nx and vx. Okay, what you can do is you just solve for the two simultaneous equation. Okay, so now probably I give you 2 minutes, okay, to solve for the nx and vx. I will show you the answer, yeah, after 2 minutes. Okay. I remember that the function in your calculator is able to do that. Why not? You can try directly using your calculator, even though my next slide is using manually. Two simultaneous equations. I think I have one request. What happened? Wait. "12 minutes." Intan said. Okay. So, are you able to get your Vx and Nx? This value?
Yes.
Okay.
Same as you.
Congratulations. Okay. For those who have not used the calculator to directly solve it, you may try it later. Okay. So Nx, if you can see that, we get a positive value, which also means the compression force is within the this arch. Okay. Of course, we can determine the mx as well in the system. Okay, just take the summation mx equal to 0. Okay, you get the mx here. So now let's go quickly here. Okay, if you are to apply the methods or that we want to get the fast, okay, we write the internal force here mx equal to, then the m applied happens at the next. Okay, if this is M internal. Okay, if the M apply same direction with M internal, we give it negative value. When the M apply opposite, what's that? Opposite direction with M internal, we give a positive value. Okay, so if it is same direction with my internal moment, I give negative value. If it is opposite direction with my internal moment, I give a positive value. Okay, so now my M applied will comes from 29. Okay, let's see. 29 and the perpendicular will be looking at 4.24. Okay, so this is acting counterclockwise. So it is same direction with my internal moment, so negative. Okay, then I take from 131, and the distance to the x will be talking about 1.76. Okay, 1.76. And now it is acting about x clockwise. So it is opposite with the internal moment. So I put a positive moment. And then will be the 60 kilonewton. Okay, so it will be 60 and the distance will be 0.96. And it acts about x is counterclockwise. Same with my internal moment. So I also give a negative here. Okay, so this is my, once you solve it, it will be my mx internal moment. Okay, which is 50 kilonewton meter. Okay, so if you are okay, we will have a break of maybe 5 minutes or 4 minutes. Okay, while I'm checking the attendance of today's class. Okay, you may ask questions during the time as well. Okay, we're going to go for parabolic arch later. Okay. Okay, my class, can you maybe I do not put a refresh. Let me put a refresh first. Am I? Why? Yeah, I think I have wrongly put in the times. Yes. Is this for this class too? Yes. So let's check again. Okay, now you can help me to take your attendance. Okay, I think you cannot join in, right? Am I right? Hi, class. Can you take your attendance? Yeah. Sorry for that. Yeah, today I have been miss around with this timetable. I I start my I start entering my this team early at 10 and realized that my class actually start at 11. Okay, same with this class. I actually thought that it is 2 to 4. Okay, so now can you help me to put in this attendance, okay, before we start the next example. Okay, so how about our participants today now? Is it full? We have 2 more students not joining. What happened? I thought just now we have almost full. This is not Thursday. Today is Wednesday. Okay, class. Can we go to for parabolic arch right now? Maybe for this example, I can fasten my explanation because the similar process apply. Can I start?
Yes, madam.
Yes.
Okay.
Yes.
Yeah, thank you. Okay, so now I have this parabolic. If you can see that the radius will not used, okay, in this parabolic arch calculation. Okay, but we have equations to help us to determine all the different, height at different location. For example, now I want to determine the YB, the height at B, okay, YB, and the height at D. Okay, we will use the equations that I've shown earlier. Okay, so these are this is the equations. Okay, I shown in the earlier slides. Okay, let's see how to apply this equation. Okay, so this equation is purposely for parabolic shape of arch only. Okay, so now I want to determine YD. Okay, my equation is 4yc over L squared in the bracket Lx minus x squared. Okay, so yc will be the rise, okay, which is measured from the spring line to the crown. Okay, this is yc. Okay, so yc is 7. Okay, for both of the yd and yb, you can know that this is 7. Okay, and L. Okay, L is fixed. L is actually I shall not say that the L is from two supports. Okay, we shall make sure the spring lines the same. Okay, for A and B, meaning that you need to actually project, okay, the curve, okay, down, down to have the same springing line, okay, with A. Okay, only you can know what is the L. So be safe, your L, you take the from the spring line A, let's say, okay, to halfway of until your crown. Okay, halfway. So this will be L over 2. Okay, so once you know this is L over 2, you just multiply this value, you get the span, the L. Okay, so meaning that this B, when it project down, okay, so you need to extend for some of this distance. Okay, so let's say L over 2 is how much, class, for this case?
15.
Thank you. 15 meter. Therefore, the length, the span, okay, it will be 30. Okay, here. Okay, so similarly in for your YB. Okay, next, we need to put in the x value. Okay, the x value will be measured from A. Okay, so for example D, you need to measure horizontally to A. So we are going to use the 7.5, okay, for the x. Okay, if you want to determine the YD. Okay, how about for YB? So you need to also measure the length from A to B. So which is also 25 here. Okay, because this is already 15 and then plus another 10, you get to 25 for your x. Okay, now everything is here. You just need to solve for the equations. You get your YD and your YB done. Okay, similarly, from the circular examples, we can determine the support reaction by considering the whole structure. Okay, and also considering the cut section where you cut at the hinge. Okay, so now here I list down a very the procedure here. You consider the overall moment, okay, and then you consider the cut section at C. Okay, then you choose either you want to analyze this section A or section B. Choose which one is easiest. And in this case, B is chosen because B there is no section BC, there is no loads on it. Okay, so let's have a look on the next slides. So support reactions, one, you already know this YD is 5.25, YB is 3.89. Okay, so you're considering the overall structure. Okay, no cut section yet at this stage. Okay, then you can, but now the A and B, yeah, they is not at the same level. So you will get the this two simultaneous equation. Okay, where you need to solve it. Okay, so now you take summation MA equal to 0. Okay, so from the overall here, okay, you will need to consider the 10 kilonewton per meter. Okay, Bx and also By. Okay, so please study later on how to put in these equations. Okay, you will get the equations 1 done. Then you can't after you considering the overall system, then you cut a section at C. Okay, then you considering the sections CB now. Okay, so maybe it's not drawn here, then you can draw a free body diagram here. Okay, where you have Bx and By, and you also have this internal forces at C. Okay, but if you are taking summation MC equal to 0, then the you won't consider these CY and CX, but you can draw it. Okay, maybe you want to draw this. Okay, so now taking this summation MC equal to 0, so you just need to use the By and Bx only. Okay, so now you have both the equations 1 and equations 2 consists of Bx and By, the two unknowns. Then you can solve for this two simultaneous equation. Okay, so you can solve for the Bx and By. Any questions up to this?
No, no.
Oh, okay. If
No.
you really have question, please, you need to raise it up. Okay. If not, I will not know. Okay, you have this question on which parts. Okay. So now you already solve for the Bx and also By. Okay, what you can do next is to solve for the remaining support reactions, AX and AY. You can use the summation Fy equal to 0 now, okay, and summation Fx equal to 0, okay, to solve for the AY and AX. Okay, I would like to move further because what is our problem here? We want to calculate all the support reactions where we already done for this, and we also want to determine the internal forces like bending moment, normal thrust, radial shear at the point D, okay, in the parabolic arch. Okay, so at D, at point D only. Okay, so we need to cut the section at point D right now. Okay, so at point D, when we cut the section at point D, so meaning that you are considering section AD. Okay, so when you are considering section AD, you need to put in all the forces in the system in this section. So don't forget about the external load, 10 kilonewton per meter. Okay, your support reaction, AY and AX. Okay, and then also your internal forces, the ND, okay, the VD, and the bending moment. Okay, so we can start writing the horizontal component acting on at D, okay, and the vertical component. Okay, how to do that? It will be similar as the previous example. Okay, so what else? Then you can, yeah, we will just repeat whatever we have uh, shown just now. But I do not show you here. I just show you the answer. Okay, because I want you to work for it. Okay, probably we can take some times to work together for this. Okay, prepare all your exercise book. Okay, can you first write the horizontal and vertical components? Okay, the acting at D. Okay, due to this ND and also VD. Can you do that now? Okay, for uh, maybe 3 minutes. Okay, I'm going to snap this and then put in your uh, WhatsApp group. To A to P. Okay. Now we need to proceed with the exercise that I posted into your WhatsApp group. Okay. Uh, yeah. Please try that now. Okay. And I can't. Do you have my notes right now?
Yes.
Yes.
Okay. Then because I don't want to show my screen because I will be writing something also, and I would like to show you after this minutes later. So what should I do? Should I just show you future? Okay. So I would come back to you about 3 minutes later. So right something. If you have any question, you can ask. Where is my slides? I'm solving the theta right now. Okay. Mm. What is your theta? Have I left the group? Are you still with me?
Yes.
Okay, what is your progress right now?
Still calculating.
Okay, calculating what?
Theta.
Theta. Okay, do you know that you have these equations to help you?
Yes, yes.
Mm. Okay, so I will wait maybe another 1 minute to show you the theta calculation. Okay, while I'm trying to solve this equations. Okay. Mm. Mm. What's this? Okay, I will show you right now the to connect. Okay, so this is the equations for you to determine your theta. Can you see my slide right now?
Yes.
Yes.
Yes, yes. So you can use this tangent theta equal to 4yc over L squared multiplying L minus 2x, okay, to get your theta. Okay, so I have take back the yc information earlier. Okay, yc is 7 for this case, L is 30, okay, and the x right now is the length measured from A, okay, which is 7.5 here. Okay, may you check? Okay, my answer is that theta 25 degree. Okay, you check. So I'm going to go to look at my this. I'm still taking this my earlier uh, slides here, where I need to find these horizontal forces Fx at x. It is now not x right now. This is D. Okay, yeah. So okay, and this I think the same thing applies here, where we have a minus nd cos. Now the theta is 25. Okay, plus Vx or Vd sine 25. Okay, so I think everything is still the same. And minus nx sine 25 for vertical force, minus Vx Vd cos 25. Okay, I think this, oh yeah, what happened to this? Okay, so this applies. Okay, I just group it there. Okay, then I would like to write my summation Fy and summation Fx equal to 0, just like what I have done for my previous examples. So I will just delete this and write it now. Yeah. So now writing this will be referring to the systems here. Summation Fy, I have to consider the 120 kilonewton, which is upward positive, and minus the 10 times 7.5, okay, which is the UDL, which act down, so I put a negative there. And then with my vertical components here, okay, which is a minus nx sine 25, okay, minus Vx cos 25, okay, equal to 0. I can also put it create my first equation, sine 25 minus Vx cos 25 and equal to, okay, 75 minus 120. Okay, you can solve for this. I have put it is the first equation, and the summation Fx, it will involve my Ax 96.4. Okay, and the horizontal components now. Okay, minus nx cos 25. Okay, plus Vx. Okay, sine 25. Okay, so I can correct my second equations by putting minus nx cos 25, okay, plus Vx sine 25 equal to minus 96.4. Okay, this is my second equation. So I will solve these two simultaneous equations. I will solve my nx and Vx. Are you okay, class?
Yes.
Okay, so what is your nx and Vx? Have anyone found the value? Okay, so let's say you already found the value. I'm going to find the moment now. Okay, so wait. Okay. So now I want to determine the moment. Oops. Do you want me to wait here for a while? Class, I need your feedback. Do you need me to stop for a while here?
It's okay, just continue.
Okay, so all right. But have you found the nx and vx?
Still calculate.
Still calculate. Okay, so you are still calculating and you want me to proceed, huh? All right, so I have my nx and the vx, or you want to put it more specifically to the point D, there is no problem, nd, vd. Okay, so I can also determine my md right now. I'm going to erase this whole thing. Okay, so I'm going to take a summation. Okay, md equal to 0. Okay, which I will not involve any nd and vd in this calculation. So I will just need the 96.4. Okay, 96.4 and the 5.25. Okay, it adds, so I put a negative there. And then I have another one is 120. And then with my distance to D is 7.5 meter. Okay, and it is acting clockwise. Okay, positive. And then I have another one which is acting counterclockwise. Okay, which is 10 times 7.5, the resultant force from the UDL, multiply with the distance to the D. Okay, 7.5 by half. Okay, and that's all, equal to 0. Missing something. Anyone can help? Hi class, can I point on somebody to answer this? Let's have this Kairunisa. We are getting lesser and lesser students in my class now. What happened? Kairunisa, can you help? We are missing something in this equation. What is that? Kairunisa, are you here with us?
Yes, madam.
Yes. Okay. Can you find what is missing in this equation? Anyone can help?
Moment at D.
Thank you very much.
Plus
Okay.
MD.
Yeah, thank you very much. MD is positive or negative?
Negative.
Okay, negative. Fair. So now you have your, can solve for MD equal to how much? Okay, I think I can help until this here. Okay, you need to calculate the ND, VD, and MD. Okay, I have shown you the equations here. Okay, you need to solve this simultaneous equation for ND and VD. Okay, and these slides you need to solve for this MD. Okay, so you shall be able to obtain the VD, ND, MD with this answer. All right, class. Do you have any questions for me for this class or for your I discuss tutorial questions? Okay, maybe I will stop the recording first. Okay, class, I'm waiting if you have any question for me.
No, I don't.
No, huh? Okay, if you don't have any questions, okay, I will see you next week for uh, a lesson on how to determine the deformation for a system that consisting involving arch. Okay, and then I will also show you on how to determine the deformation if we have a composite structures. Okay, these composite structures means we have this now from week 1 to week this is week 3. We have actually learned the axial type. Okay, axial force. Okay, axial force types of structure, which is truss system, and then we also look at the bending moment type of structures like beams, frames, and arch. Okay, what if these two types of these structures, okay, combine? Okay, then how to combine these virtual work equations? If you still remember, for the truss we have NNL over AE. For the beams and frames or arch, we have this. We are going to, for the arch, it is actually the same with beam and frame. We will have M. What is the equation, class? Okay, integration of small m, big M over EI dx, which is being introduced to you last lesson. Okay, so if you don't have any questions for me, okay, you may leave the class. Okay, I wish you a happy day, okay, for tomorrow public holiday. Okay, and if you have question, you may remain the class and I will answer your question. Okay, thank you.
Thank you, madam.
Thank you, madam.
Thank you, doctor. Sorry for not involved so much.
As long as you understand, okay, that will be good. Okay.
Yeah, try to catch up with your the what you say lah. Sorry
Yeah,
for not involved.
yeah, yeah. I have also quite a worry when the class is not responding well. I do not know whether this is the class has been effectively conducted. Okay, you need to give me feedback. Okay, whether my lesson is just too fast for you. Okay, so that I can control it. Okay, just to make sure you understand. Okay.
Maybe just yeah, okay. Maybe just today only lah, because before this I still can, but right now maybe there is too much about working need to be done. So I need to faster my writing. So that's why I not so involved when you ask.
Yeah, actually, I try to give some exercises in the class as well, so that we are actually practicing using the class time. But for me, of course, it will be not that effective because I have so many things to share with you. If you can see that if we are practicing together, we might take more time. Okay, but I will try to incorporate that. Okay.
Okay, okay, doctor.
So any others questions from class?
So far nothing lah.
Okay, thank you, Zoo. Okay, I can see your face actually.
Okay.
only you and
Okay,
Shafika.
thank you. Bye. Have a nice
So
day.
yeah, I can at least when you come to my office next time, I can recognize you.
Hopefully next semester.
Yeah, hopefully we can pass through this terrible time. Yeah. How about the rest? Are
Yeah.
you
Okay,
asking?
stay safe.
Yeah, yeah. You stay safe. Huh? How about the rest? You want to ask me question? Is it Shuhada?
Madam,
Yeah, Ahmad.
where can I find the previous lessons yang recorded?
Recorded.
Yeah.
Are you new in my class?
No.
No. I think every week at the end of the week, I share you the link for the recorded video.
Oh, so the link.
Can you watch the video by the link? Because because I never try the link. I just copy from the Microsoft Stream.
Oh, the link
Can you try
will.
now, Iman? Can you go to our WhatsApp group, looking
Yeah.
at the link given to you last week?
Oh,
Can you
last
click?
week.
You try to click now.
Okay, I will
Press.
try.
And how about Shuhada? You want to talk right just now? How about Faris? Hmm. Shamimi?
Madam,
Yes.
macam mana nak cari moment internal yang same ataupun opposite direction tu?
Okay. Then I will show you right now.
Yang dekat circular, yang dekat circular arch.
For the arch.
Uh-uh.
For the arch. Okay.
Circular.
Circular arch. Actually, it is same like these beams. But do you know? Do you comes to my lesson, the last lesson?
No.
Really? All right. So maybe I don't want to talk about this arch. Okay, maybe we can use the beams to explain again. It would be better. Once you know how to apply the beam or frame, you will sure apply to arch. Okay, so I show you now. The rest, do you have any important things for me? Okay, I will show for Shamini. Yeah, where is my? This is a beam. Okay, so maybe let's try. I think I talk about during the deformation of beam open. Maybe just a simple one first. This one. Okay, so let's have a look on this this one. Okay, so I'm drawing a cut section for this. Can you see my slide? Anyway, Shamimi.
Yes, I can see.
Okay, so now I'm referring back to this cut section for these beams. I'm taking a section. I'm considering section BA, meaning that this is not in my eyes right now. I only see this only. Okay, this part only. Okay, so now I need to put in all my this internal force here to draw my free body diagram. But now I concern on my moment only. Okay, to show you the moments. How to take these moments? Okay, so of course you can write the concept also comes from actually taking moment at x equal to 0. Okay, there is nothing so special about that. But because now we deal with many primary structure, virtual structure, and if you are into chapter 2, you have so many virtual structure. It will come up to 3. So you need to analyze 4 structures to just to get the answer. So we might not be able to finish that question. So you need to that is why my advice to you is you need to quickly get along with me my lesson. Okay, so now I will name these moments into 2 types of moments, Shamini. So one is the internal moment. I name it, M internal. Okay, so M internal will happen at here only, which is also the MX at the cut section. Do you get me?
Yes.
Okay, and another moment I name it is I name it. Okay, you can name otherwise. Okay, I name my other type of moment is M applied. Okay, M applied is any other moments aside from this M internal MX. Okay, that happen to this cut section due to external load or any support reactions. Okay, so now I have, because I want to get my MX written fast, so I have to compare this M internal and M applied. Okay, so I put a guidelines here. If my M internal and my M applied same direction means they are acting either clockwise, both of them clockwise. Okay, then my moments applied will be positive moment applied. Okay, but if it acts at oppositely, which means that M internal is clockwise and my M applied is counterclockwise, then I give my M applied negative. Do you get what I mean now? Okay, so now MX, I will directly write my moment equations here. My MX will be my M internal. I write it immediately and then I put the equal to, which I actually means to get all my moments that's being considered for applied to the other side. Okay, M applied here. I put it at the other side. So what in this case, I only have this external load of this 12 kilonewton per meter. If I consider X running here, okay, I can have a resultance of this UDL is 12X, right? Can you get this 12X?
Yes.
Okay, and the distance to the cut section is actually X over 2. Are you able to get this X over 2? Okay, so the moments here to the cut section is actually 12X multiply X over 2. Okay, so now I need to compare here. Okay, these external loads, okay, or M applied here will act what direction? Clockwise, right?
Clockwise.
Yes, clockwise. So it is same with my M internal, right? MX. So if it is the same, so I just put negative here. Okay, this is what I have been mentioned in my slide just now. So yeah, because previously you write a long one, right? You write MX plus 12X X over 2, right? Then you write MX equal to minus 12X X over 2. So what I actually, I want to skip this. I want to skip this step and I directly give this, write my bending moment. Okay, but still you need this knowledge. Okay, this knowledge is important. Okay, okay. Any other questions from the floor? Ame, I think you want to talk to me.
No, madam, nothing.
Tak jadi. So any other question?
So far so good, madam.
Okay.
Tapi madam, kalau saya ada problem pun saya boleh WhatsApp madam tak?
Oh, saya memang menunggu. Cuma tak ada orang message saya. Cuma seorang dua saja. Macam itulah.
Okay.
Saya pun sangat rasa sangat happy ke? Semua orang faham saya punya kerja, tetapi saya tengok balik itu tutorial I discuss, tak ada orang submit. Jadi saya pun bingung apa masalah ni. Are they understand my lesson or not? Macam itulah. Jadi ada apa-apa masalah, you write to me. Jangan you don't expect me to give you answer. Saya tak mau buat begitu. Jika saya buat macam ni, you tidak akan belajar. But I will guide you. Okay, I will tell you what to do next until you get your answer. Okay? All right. If you don't have any more questions, Okay, then we will end the class today.
Madam.
Okay, bye.
Thank you, Doctor. Bye bye.
Okay,
Okay, madam. Thank you.
okay ya. So text me lah. Seorang lagi Aiman Arif. Dah boleh tengok recorded video?
Yes, yes.
Boleh ya?
Dia pergi dekat Chrome.
Saya tak pasti tapi nampak tak dia punya video tu?
Nampak.
Boleh lah tapi panjang 2 jam. Pening.
Sebelum ni saya cari dekat Microsoft Teams tu. Tak ada.
Saya tak pasti dia store dekat mana lah tapi saya boleh get it back from Microsoft Streaming.
Oh.
That is why saya setiap minggu, akhir minggu, saya akan ambil balik dia punya itu link dan saya share pada kelas. Okay, week 1 saya pun sudah share, week 2 saya pun sudah share. Hari ni punya saya akan share lah nanti.
Okay, madam.
For those lah who has internet problem ke dia tak boleh ikut sepenuhnya, they might be able to look lah back. Okay?
Okay.
Boleh nampak kan?
Boleh.
Okay, bye.
Okay, thank you.
Thank you, madam.
Okay, bye.
Bye-bye.
Faris, do you want to talk to me?